reconstructed Great Kiva at Aztec Ruins. I'm Ranger Justin, and one of the things I like about being a park ranger is being able to talk about archaeology with people just like you. The reason being is, outside of being a park ranger, I'm also an archaeologist. Aztec Ruins was built in the early 1100s and occupied for about 200 years. In it, the engineering is something to be admired. So if you're ready, we'll get into it. The roof of the Great Kiva weighs about 95 tons. Supporting that 95 tons is 4 pillars. And the engineering behind that is pretty amazing. To talk about it, we're going to start from the ground, or rather under the ground, and work our way up. These 4 discs, weighing over 350 pounds each, are made of solid limestone. They were brought in from miles away, and the way they used them is pretty ingenious. At the base of these pillars are those 4 limestone discs. What the ancestral Puebloans did is they dug a hole beneath the floor, lined it with stones, and then filled it with lignite, which is a step above peat, but a couple steps below coal. It's a relatively soft rock compared to the 95-ton roof. They put the discs in and sandwiched that lignite in between. And the reason being is because on wet or heavy snowfall years, this ceiling would be more than 95 tons. And it may be uneven across all 4 pillars. So the pillars themselves would need to adjust for that. So this was an early form of basically a shock absorber. 1,000 years later, modern people use that same technique, though updated, for building skyscrapers in earthquake-prone areas. Now, up and down motion isn't the only thing you've got to adjust for. The roof wasn't made with nails or rebar like we do nowadays. Instead, it was laid with wood and dirt and plaster, and so shifting might happen as well, both side to side and up and down. To combat the side to side motion, they did this. As you can see, there are courses of stone here with courses of wood in between. That allows a little bit of shifting side to side. The reason being is if you had a solid pillar built on solid ground, the shifting of the ceiling would cause it to crack and break. And it only needs to fall down once and kill your buddy, and you won't do it again. The people at Aztec Ruins had thousands of years of trial and error to come to stuff like this. These people didn't have engineering degrees or colleges or anything like that, nor did they have metal tools. Yet they did things and techniques that are used thousands of years later. The north wall here is another engineering feat. Standing 3, possibly even 4 stories tall, is lined up with the summer and winter solstice. We know how tall it was based on the width of the base of the walls. The doorways themselves were engineered for a specific purpose. The low ledges, the high floors, it all served a purpose. And that purpose was to keep inside here a pretty constant temperature. Hot air rises, and as such can't escape. Cool air falls, and as such can't escape either. So these rooms would stay around 73 to 76 degrees fairly continuously throughout the year. Here at the overlook at Stop 18, it's no wonder this place was made a UNESCO World Heritage Site in 1987. But honestly, the best way to experience this is by yourself. So we invite you to come out here and partake all that is Aztec Ruins.